are on learning objective 22, define periodicity, periodic law, and representative elements. So Dmitry Mendeleev was the first person that is accredited with the organization of the elements in a periodic table. Okay. Now, his table looked a lot different than our table does now. Mainly, it had a lot fewer elements on it. But again, he is the first person that is accredited with organization of the periodic table of elements. He organized the elements by increasing atomic mass. Okay. Now, there are several places within the periodic table where we see where there is a decrease in mass instead of an increase. And we're going to talk about 3 of those. Okay. So 3 major problems with Mendeleev's table. At least he saw these as problems. Or maybe he didn't see them as problems. The first was argon and potassium. So if you look at argon and then you look at potassium on the periodic table, so I've got argon here and I've got potassium here, you can see a definite decrease from argon, which is 39.95 to 39.10. So that's a definite decrease there. So what we find is that Mendeleev's kind of explanation for this discrepancy here is that noble gases were not discovered at this time. So noble gases, so for instance, argon was not discovered at his time, during his time. So he didn't really mind that one. He didn't know about this one. So again, didn't know that there was a difference in mass between argon, that argon's mass is higher than potassium's mass. The second area, the second place that we see an increase or decrease instead of an increase is cobalt and nickel. Now, cobalt and nickel were discovered at his time, during his time. So they knew what cobalt was and they knew what nickel was. Okay, so cobalt and nickel were both known during his time. And if you look, I've got 58.93 and 58.71. And basically what he said is that these were really relatively close to one another. So he looked at the properties in order to place them and where he placed them at. And you kind of also have to think this was back years prior to this, and we didn't have the mass spec and that type of thing that we have now. So we didn't have the equipment or the instrumentation in order to accurately measure the masses of the elements. Now, something interesting about cobalt and nickel is that he did place cobalt with iridium, and he did place nickel with palladium. So he did place these in the right order, which is kind of interesting in and of itself, because if you really would have thought about it, he probably could have just kept them, nickel in front of cobalt, but he didn't do that. He put cobalt in front of nickel because of the properties that cobalt had versus the properties that nickel had. The last one that caused him so much, essentially, was tellurium and iodine. So let's look at this one. both of these were discovered during his time. Again, both of these were discovered during his time. So we've got tellurium, which is 127.60. And then we have iodine, which is 126.90. So tellurium is 126.20. Tellurium is 127.60. And iodine is 126.90. 127.6, 126.9. Now, that's a big difference. That's a pretty good size difference. If I rounded those to whole numbers, I've got 128 and I've got 127. So that's a pretty good size difference there. So this was a big problem for Mendeleev's OCD. He couldn't understand why tellurium had such a higher mass than iodine. And it bothered him a lot. So this one gave him his big problem. So this was a big problem for his OCD. He was really OCD. So what he found was that iodine had properties that were similar to bromine, chlorine, and fluorine. Okay, so these had properties that were alike, that were very similar to bromine, chlorine, and fluorine. And then that tellurium had properties similar to selenium, sulfur, and oxygen. So, guess what he did? He switched them around. Now, again, he could have, if he were really truly following his whole thing, he could have flipped iodine and tellurium. But he recognized that if iodine has similar properties to bromine, chlorine, and fluorine, then iodine probably is supposed to be in with those guys. So they're part of this really fancy group, I guess you could say, right? They're like this little clique on the end right here. And because tellurium had very similar properties to selenium, sulfur, and oxygen, and how it bound and its chemical properties and its physical properties, he placed tellurium with those elements. Again, very cliquish, right? That type of thing. So, what did Mendeleev discover? The big thing that he discovered was he discovered the periodicity of the elements. What periodicity is the tendency of a phenomenon to repeat. So periodicity is the tendency for a phenomenon to repeat regularly. So think about your life. Think about the things that you do in your life, right? So you probably have soccer games, or you have soccer practice. Maybe you have baseball practice. Maybe you have, color guard practice or band practice or whatever you're involved. Have a birthday, right? Your birthday comes at the same time every single year. So essentially, your life is run by this idea of periodicity because you have things that repeat regularly within your life. You come to Mrs. Cole's class every day, depending on. You have periodicity in your life. It's your schedule. That is what we're talking about here. So your life is run by periodicity. And I could say that my life is run by periodicity. There are events that repeat regularly in your life all the time. So again, example, band practice, birthday, whole bunch of other stuff, right? TV shows. What city does is it gives rise to this periodic law. So periodic law states that when the elements are arranged by increasing atomic number. So like the number of protons. The properties of the elements repeat. So modern periodic table is organized by atomic number. Again, this is the number of protons, right? It has rows and columns. So the rows are called periods, and they follow periodic law. So again, those elements, when arranged in increasing atomic number, the properties repeat regularly. So they repeat every row, right? So elements have different properties across the row. Okay, so as we go across the row, the properties are different between the elements. As long as we're on the same row. I mean, even if we're not on the same row, it's still different properties, right? And then you have columns. So the columns are called groups or families. Okay, and these guys have the same number of valence electrons. Which makes them have similar properties to one another. Okay, so again, my columns are my groups or my families of elements, and they have the same number of valence electrons, which makes them have similar properties. Valence electrons are the electrons that are in the outer shell. So if you want to skip ahead a little bit, these are the outer shell electrons. Okay, so valence electrons are the electrons that are in the outer shell. So we have the last definition that we've kind of got to cover is the representative elements. So the representative elements, or the AKA main block elements. So the main block elements. These guys are located in groups 1 to 2, and then 13 through 18. Okay, so if I'm looking at this periodic table, I'm looking at (13 through 18) and 2. Okay, so this and this are the main block. Okay, so main block. Okay, so main block. That's what the representative elements are. Okay, these elements are easily predicted by periodic law. So these are your definitions for periodicity, periodic law, and representative elements. This also kind of tells you how Mendeleev discovered periodicity, which is the tendency to repeat regularly. And then periodic laws, when elements are arranged in increasing atomic number, properties repeat. And then the representative elements are the main block elements, which are in groups 1 and 2, and 13 through 18.